Welcome to Developer Stories on the Road to MSIX, a podcast for developers that are interested in updating their installers to MSIX. I'm Tim Mangan. In Chapter 3, we'll take a look at the package file system and whether or not you need the VFS. The MSIX runtime has a parallel to the virtual registry I discussed in Chapter 2. It's called the Virtual File System, or VFS for short. It acts as an overlay, allowing you to have your package files as a transparent layer over existing system file locations. Now, you don't necessarily need to use the VFS. Many simple applications that don't use a lot of directories, and code that creates strings to hold file paths by querying APIs like the known folder IDs, these can be packaged with the application files placed in the root folder of the package. You can even have subfolders there as long as any string created for the file locations are based on the location of the execution assembly path. But quite often, older code is better off by just placing the files in the package under VFS folders that are the equivalent to where they would have been put natively in your installers of the past. So let's say that natively, your app installs as shown on the left. If you use the VFS, those files will be placed in the package areas as shown on the right. When your package gets installed, it probably means those file paths look like this, although alternate install locations are possible, so you can't depend on that exact location. Now, the way your app is written, you might construct the path to find foo by using the execution assembly path, or maybe the working directory, or the known folder ID for program files. The first two approaches, execution assembly and working directory path, should yield the result of exactly where the file is located, even though it's now in the container. But if your existing code uses the known folder ID, then it will look for the native path. But since MSIX provides this overlay, it first is going to check the file under the VFS path, and then the installed location that was requested for in order to find the file. And it should be successful. Your app source code today might now construct a path to find foo by using the execution assembly path, the working directory, or the known folder ID for program files. The first two approaches, execution assembly and working directory path, should yield the result of exactly where the file is located. But if your existing code uses known folder ID, it will look for the native path. Fortunately, since the MSIX runtime provides us with this overlay, it's first going to check the VFS location within your package before looking to the native system path. Here is another example that demonstrates file enumeration. Normally, you might install one of your 64-bit DLLs into the Windows System 32 folder, well, on a 64-bit OS. In the package, if you put it into the VFS System x64 folder, then the actual install location probably looks like this. But now your code decides to enumerate all the files under that folder. And let's say that outside of your package, there are other files in that native folder. No matter which folder your application asks for, the native or package path, the system is going to return the same thing. It will return a list that contains all of the files from both locations. If the same named file exists in both locations, only the one from your package is returned. Now, this sounds great so far, but unfortunately, the base MSIX runtime only does this for certain VFS folders, namely the Program Files and Program Files Common folders, and anything under the Windows folder. With the addition of the Package Support Framework, or PSF for short, in your package, you can place all of the files in VFS folders and have them layer mapped the same way that we do with the runtime. Now, we're not going to get into the PSF here. That'll be the subject of one or more future chapters in this series. But basically, this means adding the PSF launcher and MFR fixup to the package. Here's a summary of how that layering works. Using the VFS paths allows your application to think that it has been installed in its normal location because all of the file requests will see the app as installed there. This keeps you from updating your source code for many of the common path calculations that your apps make. And in case you think this is something new, we've been using this same technique in Windows for over 25 years in the form of Microsoft AppV. It works really well. So, do you need the VFS? Well, maybe you don't. Maybe your application package is simple enough that you'll be able to do it just fine without it. But if you start having some difficulty, if you have an old, complicated app with lots of executables and folders and directories, chances are you're going to want to use the VFS pathing. Now, some other common issues you might run into include the two items that we should talk about, because if you run into these, you're likely to think that you have a file problem when in actuality you don't. For example, the app might not be able to find its DLLs, and it might not be able to find some other assets. We'll tackle these in the opposite order. Now, traditionally, the working directory of your application executable would be the folder that the exe lives in. Now, this could be altered either by starting the app by using an LNK file for the start menu that sets a different folder, or possibly by the application at runtime. Now, we'll leave that last one alone today, but let's recognize that your package does not use an LNK file to integrate into the start menu. It now uses an entry into the AppX manifest file. The original design for the AppX manifest file did not support specifying the working directory, and the appropriate folder wouldn't have been set. Now, this is fine for a simple AppX app. Quite frankly, in most cases, they don't really care where the working directory is, but this could well be a problem for you. A more recent extension to the schema set now supports this. It is the UAP11 current directory path, and it allows you to specify the initial working directory path just like the LNK file did. And you should do this in your AppX manifest, but I will warn you that the current WAP doesn't do this automatically. But be aware that while UAP11 is supported on all versions of Windows 11 currently supported by Microsoft, Server 22 is still a supported operating system used by many large enterprise customers, where they aggregate many users into a single system with things like RDS, Citrix, Omnissa Horizon, Parallels, and others. And UAP11 is not supported on Server 2022, which has standard service support valid through 2027, plus the enterprises can pick up another 5 years of extended support if they're willing to pay more. Oh, and by the way, the 11 in UAP 11 does not mean Windows 11. It just happens to be the 11th revision of the UAP portion of the schema set. We're already up to UAP 17. To ensure that this isn't a problem for all your customers, without you needing to change your code, then you'd probably have to add the PSF launcher, which would set the working directory that you specify in a config.json file. And oh, by the way, there's a similar story about command line arguments. The solution here is called UAP11 parameters element, with the same restrictions of OS versions I talked about before. Or the PSF launcher, you can put the arguments in the config.json file as well. Your application today might use a couple of techniques to enhance the DLL search order. Hopefully your installer no longer touches the path variable, but you might be using app path registrations. This is where you name your exe by name, not by path, and then specify a list of additional folders to search in. Without a traditional installer, you can't change the path variable, which you shouldn't have been doing anyway, but any app path registrations that you do aren't usable for MSIX. They'll be ignored. As your application likely loads DLLs by name alone, this means that you might not find some of your DLLs when you first try to run your software inside the MSIX container. The simplest thing to do is just to organize the DLLs within your package in places that the MSIX runtime would automatically check. Now, this can mean placing them directly in the root folder of your package, but only if you don't have 32 and 64-bit DLLs that have the same name. But a better solution might be placing them in the VFS System x64 folder or VFS System x86 folder as appropriate. A third technique is to use a loader search order element in the AppX manifest file. This allows you to specify up to 5 folders to add to your search order list. Now, 5 is enough to handle most applications, but I've seen a number of applications that go well beyond that. But if you can do that, you would simply add that element in, and you would use the relative paths to the root folder of your package wherever those folders are. Here are some useful documentation references regarding the virtual file system. The Microsoft LearnDoc is honestly an introduction, but it is a little bit weak on the technical side. But it does make a good starting point. The wiki documentation link for the Packet Support Framework provides the best list of what those folder mappings are from the native to VFS paths. And this has been generated from our experience with both MSIX and its predecessor, AppV. This concludes this chapter of The Road to MSIX. If you missed earlier chapters, you can get them from the Tmergent LinkedIn page or our YouTube channel. Keep an eye out for new chapters too. You can see some of the ones that we're planning here. But I'd also love to do a podcast with you about your experiences in creating MSIX packages. Just contact me on LinkedIn. I'm Tim Mangan on The Road to MSIX. Thanks for listening.